Hi, welcome to the first video on shapes that we're going to do. We're going to look at 2D shapes today. And we're going to look at what some of the 2D shapes look like, what they're called and what their properties are. So we're going to start with a square. This is a square here. And squares have got 4 equal sides. They've got 4 equal corners. And they have got 4 lines of symmetry as well. So we're going to fill some of that information in. Okay, so this is a square. And they've got 4 equal sides. 4 equal corners or angles. And 4 lines of symmetry. Okay, sides are sometimes called edges, angles are sometimes called corners or vertices. So that is a square. So next we're going to look at a rectangle. There's a rectangle there. Rectangles look similar to squares. There are some properties that are the same as squares. However, the main difference is that it's got 2 long sides that are opposite each other and 2 short sides that are opposite each other. And the short sides are equal to each other and the long sides are equal to each other. It's got 4 angles, 4 corners that are equal sized, and it has only got 2 lines of symmetry this time. So it's a rectangle. And it has got 2 short sides. Two long sides. 4 equal angles that, just like a square, are 90 degrees. And it's got 2 lines of symmetry. So some of the properties are the same as a square, most of them are not. So next we're going to look at triangles, and there's different types of triangles. This one is an equilateral triangle. And in an equilateral triangle, all the sides are the same length and all of the angles are the same size as well. And it has got 3 lines of symmetry. So different properties for different triangles. We've also got isosceles triangles. So here's one isosceles triangle that's got 2 sides the same length. There's another isosceles triangle, slightly different. And we've got here a third isosceles triangle, but I'm going to turn it round because it is also a right angled triangle. It's got a right angle in one of its corners. And there's another type of triangle called a scalene triangle, and a scalene triangle has got 3 sides that are all different sizes from each other. Okay, so these are all different types of triangles. And as I said, they've all got different properties. The ones that they share are they've got 3 angles. That's why it's called a triangle. That means 3 angles. And they add to 180 degrees for every single triangle. If you add all the angles up, you get 180 degrees. They've also got 3 sides. And it depends on the type of triangle how many lines of symmetry they've got. So an equilateral triangle has got 3 lines of symmetry. An isosceles triangle has got 2 lines of symmetry. But a scalene triangle has got no lines of symmetry. So that's dependent on each of the triangles. In this triangle, an equilateral triangle, the sides are the same length, but each angle is 60 degrees. So this angle is 60 degrees, this angle is 60 degrees and this angle is 60 degrees. So the sides are the same. In an isosceles triangle, these ones here, we've got two sides the same. And we've got two angles that are the same size as well. So these angles at the bottom are the same size as each other. And these angles are the same size as each other. So that's an isosceles. And in a scaling triangle, everything's different. All the sides are different and all the angles are different, but they all add up to 180 degrees. Next we're going to look at a circle. This is a circle here. And in a circle we don't really talk about it having sides. It's only really got one line round the outside, and that's called the circumference. We have got a line straight through the middle of a circle. Oops. It's supposed to be a straight line, and that's called the diameter. And we've got a line that goes from the centre to the edge, which is called the radius. So round the side of a circle, we've got the circumference. Along the centre, we've got the diameter. And this little one that goes halfway from the middle to the outside is called the radius. So that is a circle. In general, you might say it's got one side, just round the outside, and the angles at the centre are 360 degrees. Right, round the middle of the circle. And that's about all we can say about the circle. You can't say how many lines of symmetry there are because there's an infinite number of lines of symmetry in a circle. Okay, so we're going to go back and look at some more four-sided shapes. So this shape's called the trapezium. The thing about a trapezium is it's got one set of parallel lines here, and it's got four corners as well as four sides. The most common trapezium is this one here that you see quite often, particularly in children's drawings when they're asked to draw pictures of houses. A trapezium would be involved in the picture of a house. So that's a trapezium. So all we can say about that is it's got four sides. In general, none of them are the same length, although occasionally you do have them with the same length. We have got four angles or vertices. And we've got one pair of parallel sides. And the way around that I've drawn them is the top and bottom that are the parallel ones, the other ones slope in. But sometimes trapeziums can be facing the other way instead. So the next four-sided shape is a rhombus. That might be quite hard to see against the whiteboard. But the rhombus is like a squashed square. Often it's called a diamond, but the proper name for it is a rhombus. And the reason it's like a squashed square is because all four sides are the same length as each other. So this is a rhombus. As I said, it's often called a diamond as well. It has got two pairs of parallel sides, so these ones are parallel and these ones are parallel, unlike the trapezium. So we've got two pairs of parallel sides. And we have got the opposite angles are equal to each other. Not all 90 degrees as they would be in a square because they've been squashed, but this angle and this angle are the same size as each other, and this angle and this angle are the same size as each other. And we've also got two lines of symmetry in a rhombus. The next next four-sided shape is this one. It's a parallelogram. It's like a squashed rectangle because we've got two long sides here that are opposite each other and two shorter sides here that are opposite each other, but the angles have been squashed. Okay, so in a parallelogram, we have got two sides, or two pairs of parallel sides. Opposite angles are equal. So just like in a rhombus, the ones that are diagonally opposite each other are equal to each other. We've got opposite sides are equal, just like in a rectangle. And we've actually got no lines of symmetry for a parallelogram. So that's a parallelogram. Our last four-sided shape, this one that I've drawn, is a kite. And it has got some of the similar properties to other shapes. We have got two short sides and two long sides. So again, it's a four-sided shape. We have got one pair of equal angles that are across from each other. The other angles are not equal. We have got one line of symmetry. And the diagonals meet at right angles. So moving away from some four-sided shapes now, I've got here a five-sided shape, and a five-sided shape is called a pentagon. And the pentagon has got five angles, five sides, and it's got five lines of symmetry. You can draw them in from the angle straight across to the side for every single angle. So we've got that for the pentagon. We have then also got a hexagon, which is a six-sided shape. So six, the number six has an X in it, and hexagon has also got an X in it. So hexagon, this one's six-sided with six angles and some symmetry as well. And the last one I want to mention is an octagon, and that word oct means eight-sided. So this one is an octagon. So it's got eight sides and it's got eight angles. There are a lot of other two-dimensional shapes that I've not mentioned. You can get ones with 10 sides, 12 sides, all sorts. But that's as many as we're going to look at for just now. Okay, good luck.